In the previous video, we were able to take a look at the table and using finite differences, look at the difference in each one of the different x values until we determined that the third differences were pretty close together, which tells us that the best polynomial function that will represent the data in the table is a cubic. So from there, what I need to do is go through and use my calculator or do the calculations by hand in order for us to calculate what that polynomial function is going to look like. When you do your polynomial functions and use your calculator to do them, these are the steps that you would take if you're going to be using a TI83 or a TI84, any one of the different versions for that. First of all, if you haven't had your calculator calculate a regression equation for you as you've been doing these problems, you are going to want to have your diagnostics on. Just let me show you how to do that. If I go to the catalog, and the catalog is way down at the bottom. On this calculator, it's in yellow up above the 0 button. So if I do second and then catalog, what that's going to do is that's going to give us an alphabetical list of all of the different commands that are on the calculator. And if you just hold down the down button, you can scroll down pretty quickly to the D's. There are other ways of getting there too. But if you look, there's a diagnostic off and a diagnostic on button, or command rather. If you just go to the diagnostic on, hit the enter button, it'll cut and paste it to the main screen. Hit enter one more time, it'll say done. Now the diagnostics are on, and the calculator will give us one extra bit of information when we go through and have it do this calculating for us to come up with this equation. So again, what we want to do is we want to take our calculator and have it come up with the polynomial function for us. That's often called a line of best fit or a regression line. And we want the calculator to do that work because it's kind of a long process to do by hand. What we need to do is we need to enter the information from the table into our calculator. So we're going to take this XY table, our X value of the years, our Y value is the population, and we're going to go through and put those numbers in. In order to come up with this equation, what most of the time our book will do is the first year that's represented in real life data like this is that you're going to call that year 0, like they're starting the stopwatch then. And when they go through and they put that into the calculator, they will use 0 for that X coordinate. So when we type this in, it's going to be 0 and then 4267. And then each one of the years after this, that's going to be the number of years after 1960, because we're basically starting our stopwatch at 1960. 1970, that's 10 years later. 1980, that's 20 years later. And so on. So when we get these typed into our calculator and we're making our XY table, we're going to be using 0, 10, 20, 30, 40, and 50 for the year. So where do you get that information typed in? Well, here's where you go through and do that. So in the center of your calculator is a button that says Stat on it, which is right here. And if we hit the Stat button, it's going to give us these options, and what we'd like to do is edit our table, which our book actually calls lists. So here is list number 1 and list number 2. That's going to be our X's and our Y's, and we're going to type in the values from our table into that spot on the calculator. You can use the arrow keys to navigate around in here, and then also if you happen to have some values, like maybe, let me just type in some random numbers here. Like let's say I was working on some stuff earlier on another problem and I have some stuff in here already, you could just hit the delete button over and over and over again, and that will get rid of these one by one. Or you can go all the way up to the top and then hit the clear button. If you go all the way up to the top, though, you don't want to hit delete because it will actually not just delete the numbers, it will delete the entire list and it won't say L1 at the top anymore. So I'm just going to go up to the top and I'm going to hit clear and then enter, and then that clears out the entire list, but it still says L1 up at the top. All right, now I'm ready. My lists are clear. I'm going to go through and I'm going to type in the information from our table. So I'm going to type in 0 and then 4267 for these first X and Y values here. So 0 and then 4267. And I could keep doing X's and Y's like that back and forth, but it is a little faster because when you hit enter, it keeps going down this column to go through and type in all the X's and then type in all the Y's. So I'm going to go through and get those typed in. So 0, 10, 20, 30, 40, and 50 in the X column. And now I'm going to type in the Y values that are here. I already have 4267 in. Let me double check those with my original work here and make sure that I get those copied in right, especially those Y values. It's easy to see the X's are right. Let's look at those Y's quick. It won't give me the right answer if I didn't type those in correctly. All right, that looks pretty good. I think we got them all in there. Once you get everything typed in with your X's and your Y's, then you're just basically one command away from having the calculator give you the equation that's going to work best for the table of values that you have. So I want to get out of this table area. I want to go out to the main calculation screen. To do that, I'm going to use the quit button, which is up above mode here. So I'm going to do second and then mode, which is the same as quit. Now I'm back out here on the main screen. I'll hit clear just to get that diagnostics on off the screen. And then here's all we need to do to finish this problem up. I want to go back into stat, which is here in the middle. But instead of going in and hitting enter now and going into edit again, which is where the tables are, I'm going to go over to calc by using the arrow button. And then if you look, there's a whole bunch of different commands. A lot of them say reg on the end of them. Those are regression lines, and that's what we're doing here. We're creating a regression line, which simply means creating a mathematical equation that fits the data as best as we can. It probably won't be perfect, but we want to come up with as accurate a one as we can. So the one we said was going to work out the best was a cubic regression. We did that in the last video and figured out that the third differences were pretty close to each other. So I'm going over to calc, down to cubic regression. I'm going to hit enter. And as long as you have put in your X values in list 1 and your Y values in list 2, you don't need anything else, and you can just hit the enter button. The calculator thinks for a minute and then gives you this information. First, there is an equation here. If you look at the very top, there's an equation there that has generic variables in it, y equals ax cubed plus bx squared plus cx plus d. And then down below, it tells you what a, b, c, and d are really going to be equal to for us in this problem. For a, we have 0.1043518,519. What our book does is rounds that off to 2 decimal places. So for a, that would be just a 0.10. And it's going to do that. Our book will round all of these off to 1 decimal place. So for us to come up with our equation, I'll get a little room to write this down here. So for us to come up with our equation for this, the calculator says y equals, but you can do y equals or f of x equals either way. I'm going to do f of x. And then the first term is an ax cubed, and I'm going to round a off to 2 decimal places, which is 0.10. So 0.10 x cubed. The next term is bx squared, and if I round b off to 2 decimal places, that's about a negative 2.83. So minus 2.83 x squared. The next term is a plus cx, and c is 109.67, rounded to 2 decimal places. And then finally on the end we have just our constant term d, which is a pretty big number this time, 4266.94. This equation right here is a cubic polynomial that represents the data pretty well. So for instance, if you wanted to see how close it was, you could plug in 0, which represents 1960, into this equation, and if you did, all these terms would cancel out except 4266.94. And the actual population number was 4267, which is really close. And if you did that, all of these are pretty close. So this is a pretty good equation for us to use. How I know it's pretty good isn't because I want to go through and calculate all of those, but because we turned our diagnostics on, it not only gave us A, B, C, and D, but it gave us this R squared value down at the bottom. You can kind of think of R squared like a percentage almost. It's not, but you can kind of think of it like a percentage. R squared goes from 0 up to 1, which is kind of like from 0 to 100%. So if you look at this number, this is really, really close to 1, or about 99.99%. It's not that accurate, but you can kind of think of it like a percentage. The closer this is to 1, the closer this is to being accurate. If it is exactly 1, then it is 100% accurate. So you can think of that like a percentage. So this is really, really good. This is a good model. The first part of the directions asked us to write a polynomial function for the data. Then it asked us to estimate the population in 2020. Well, in 2020, that is 60 years after 1960. So you would need to type in or plug in 60 for x. So if you went through and did that, you would have 0.10 times 60 cubed minus 2.83 times 60 squared, and so on. And if you did that, this is the number that the calculator would give back to you, 22259.14. So we are supposed to use this equation to predict what the population, or estimate what the population would be in 2020, and this is the number that comes out when you do that. However, it's not the answer to the problem, and here's why. All the way back in the beginning, we had year and then we had population, but it tells us in the table the population is actually in thousands, which means this. The town did not have a population of 4,267. 1,000 has 3 zeros on it. So it really was 4,267,000. Each one of these numbers, we should bump the decimal over 3 places to come up with the actual population, which is also what we should be doing here. So we should move the decimal over 3 places and then answer the question. In 2020, the population is about, I say about because it's an estimate and our equation is off a little bit. It's not perfect. Population is about, and if we take a look at this and move the decimal over 3 places, our number would be 222,59140. And if we start putting commas in, it would be about 22,259,140. So there are 2 parts to our final answer. We were supposed to come up with an equation for the cubic that fit the data, and then predict what the population is going to be in 2020, or estimate what the population is in 2020. That's how you would go through and do that problem using a TI83 or TI84 calculator.